requested to ask some questions. What type of questions? The question. They are basically given some question. There are 6 questions they have given. First question is A1 union into that event probability you have to calculate. Probability of A1 union A2. You have to calculate. Now asking, can you calculate the value of probability A1 union A2?
Yes, so we
By
can use
using
the
the
formula.
Exactly. By using the formula, you can calculate. Very good. The second case, A1 complement intersection A2 complement. A1 complement intersection A2 complement. Can you find this number? Can you find this
Yes, sir.
probability? How? By using the
As
De
a
Morgan's.
complement PA and PA complement equals to 1, that formula.
Because we know this result, student, by using the De Morgan, correct?
So,
By using the De Morgan, we know this result. But what I mentioned, that is 1 minus, correct? I mentioned na, probability of A plus probability of AC is equal to always 1, correct? I mentioned
yes,
na, whenever I started the so-called complementary event, I mentioned probability of A plus probability of AC is equal to 1. So using that result, I am writing 1 minus probability of A1 union A2. Then I am asking A1 union A2 union A3. Probability of A1 union A2 union A3. Can you calculate this value by using the formula? Exactly. The last formula that I have taught in the last class actually. Probability of A1 plus probability of A2 plus probability of A3 minus probability of A1 A2 minus probability A2 A3 minus probability A1 A3 plus probability of A1 A2 A3. Okay. So that thing you can easily calculate by using the formula in the last class that I have mentioned. Now coming A1 complement intersection A2 complement intersection A3 complement. Can you find this number?
so like the same as we did with the De Morgans, we'll use again a De Morgan.
Exactly. A1 complement intersection A2 complement intersection A3 complement. You can write simply this fashion: A1 union A2 union A3 whole total complement, and you can write 1 minus probability of A1 union A2 union A3 that you can write. Okay, but you know this number from here. You can know this number. You just put this number. Finally, you will get this number. Is it fine for everyone? Please tell me. Everyone?
Yes,
Okay.
Yes, sir.
Yes, sir.
Now I am moving to the fifth case. A1 complement intersection A2 complement intersection A3. You have to calculate probability of A1 complement intersection A2 complement intersection A3. That thing you have to calculate. Hopefully this one. A1, A2 complement and intersection A3. Okay. How to calculate this value? Okay. So tell me one thing. You have studied the so-called Venn diagram, correct? You have studied
yes,
the
sir.
so-called Venn diagram. Suppose for a Venn diagram, generally we study 3 circles. Okay, that is suppose A1, that is suppose A2, and that is suppose A3. Now you tell me one thing. Suppose this is the total region. Everyone, just look very carefully. If I am writing A1 complement, what is the meaning? Anyone? That means
So except A, all the parts.
exactly, except A, all the parts. Venn diagram is extremely important. It will help you to solve the problem. Check, I have given the double tick in right place or not. Check, except A1,
Yes, sir.
all the places I have given double tick. Then it is given as A2 complement. For A2 complement, I am giving plus. Okay, A2 complement. That means I can give the plus here actually, correct?
Yes, sir.
A2 complement, okay. And the last part is given by A3. A3 means what? The dotted line.
The dotted one.
So now you tell me, if I take the intersection, in which part the plus, double tick and dot all are common?
So the
Some
below
part
part
of
of
each.
A3.
Can I say this part?
Yes, sir.
Yes, sir.
That is the part. Venn diagram is extremely important. Anyone want to join? So this part, this lower part, is the common to all. Okay. So can I write this part in this format? Just tell me yes or no.
Yes, sir.
Correct? That is the part that I have to calculate. Yes or no? Please tell me.
Yes, sir.
Correct?
Yes, sir.
Exactly. Total is what? Total is
Total is A3.
A3. So I am writing by probability of A3. Okay. Suppose, so from A3 I have to delete which part? This part and this part I have to delete. Suppose I want to delete first this part. Okay. First I want to delete this part. This star part I want to delete. So which thing I have to delete? Can anyone tell me minus or
The
anyone?
intersection between A1,
A1 and
A3.
A3 intersection.
A1 and A3. Okay. Minus. If I delete this part from A3, so which part remains? Can anyone tell me?
So
Intersection of A1, A2,
A2 and
A3.
A3, like the part is like remaining to be subtracted.
No, not exactly A2 and A3. It is something less, correct?
Yes, sir.
Because only this part. Am I correct? Please tell me. Only this part, correct? Not this part. Because if this part already deleted by A1 intersection A3. Am I correct? Please tell me.
Yes, sir.
Correct?
Correct, sir.
Therefore, this part I can write now in this fashion. Please tell me. Probability of, I can write in this fashion. A2, A3, the total part, A2, A3 minus, what about this small part? Can anyone tell me?
So
What
all
about
the
this small part?
intersections, A1, A2, A3.
Exactly. Probability of A1, A2, A3. So if I take this, what is coming? Probability of A1, sorry, probability of A3 minus probability of A1, A3 minus probability of A2, A3 plus, correct?
Yes, sir, plus.
A1, A2 and A3. That is coming here actually. Okay. Is it fine? So now tell me, so this value becomes this one, correct?
Yes, sir.
So can you calculate
Yes,
this
sir.
number from the given data?
Yes, sir.
Yes,
Can
sir.
you calculate the number? Exactly.
Yes.
So what you learn from here, so in some scenario, you have to use the so-called Venn diagram. You have to use the Venn diagram to get the number, to get the probability. So all the data of probability of A3, probability of A1, A3, probability of A2, A3, probability of A1, A2, A3, all the data are already given in your hand. Simply just put the number, you are having the number of this. So now I'm asking to everyone, Abhijit, fine, is it fine for you?
Yes, sir, got it.
Mandakini,
Yes, sir.
Chandan, Ritobroto,
Got it,
Yes,
sir.
sir.
okay, okay. Sulagna, fine it
Yes,
is?
sir. Yes, sir. Got it.
Okay, okay. So that is the important thing, that you have to use the Venn diagram to solve this problem. Okay. So now I am moving the last case actually, that is they have asked this case, probability of A1 intersection A2, A1 complement intersection A2 complement union of A3. So the last case they have given A1 complement intersection A2 complement union of A3. Okay, that is they have given in the last case. So now you tell me one of the way to find this type of thing, that is called the Venn diagram, as I mentioned. So you can go by using the Venn diagram. Okay, another way to solve this problem, because here I have the option to apply the theoretical grounds. Here I have the option to apply my theoretical results. Why? Can anyone tell me why I am saying this? Why I can apply the theoretical results? Can anyone tell me? Because I can consider, no, this is my A and this is my B, correct? Please tell me.
Yes, sir.
Yes.
I can consider this is my A and this is my B. So what is my formula? Anyone?
Like complement of all and summation of A3.
Like this, am I correct, student? Please tell me.
Yes, sir.
So now you tell me, do I know this value from the problem?
Yes, sir.
set? Starting from the first question.
Yes, sir.
See the first question. I know this number, correct? I can add this number. Do I know
Yes,
this
sir.
number?
Yes,
Do I
sir.
know this number? Just the previous one. Check. Probability of A1 complement, intersection A2 complement, intersection A3. So now, can I calculate the total value of this part? Can I calculate probability of
Yes,
A1
sir.
complement plus A2 complement plus A3 minus the probability A1 complement, intersection A2 complement, intersection of A3. So I can easily calculate the value. Okay. So here I have the option. Here I have the option to apply my theoretical grounds, because I can think the total matter like A union B. That's why I am applying the theoretical. Otherwise, you can apply your Venn diagram like this, and this you have, and you have to simply apply the Venn diagram. Okay, that is also in your hand. But here you can also apply the theoretical result, because you can consider this as A union B. A union B that you can apply. You know this value, you know this value, you know this value. Just add these two numbers. Subtraction from this, you are getting the final number. Okay. So now, can I go to the next problem, student? Please tell me.
Yes, sir.
Yes, sir.
Can I go? Okay. So, next problem, I'm just moving. Whenever we are reading the problems, okay, everyone, whenever I'm reading the problem, we want to understand the lines each one by one. Okay, the problem that I have given, you can feel the problem I have taken from the exercise. Suppose for your this, suppose I am showing the problem. What about example 13? Please check. Is it exercise problem?
Yes, sir.
Sir.
Correct, no? So I have taken the problem from exercise problem, okay, that I have solved by my own. So right now the problem is 14. Suppose that 55% of the adult regularly, that I am reading here. See how I have solved the problem. Suppose that 55% of all adults regularly consume coffee. Okay. So suppose that 55% of all adults regularly consume coffee. 45% regularly consume carbonated soda, and 70% regularly consume at least one of the 3 products. Okay. So I am just writing the lines one by one. It is said in the question that 55% adults takes coffee. 45% takes soda, and 75% takes at least one. At least one. So you tell me, if I denote A is the event that the adult take coffee. B is the event adult take soda. Can you tell me what is the value of PA?
0.55.
Exactly, the value is 0.55, because it is given that 55% takes coffee. So therefore, P of A is given by 0.55. What is the value of PB?
0.45.
0.45. 0.45. Okay. And what is the value of A union B? What is the value of A union B?
So
Sir,
0.7.
0.55.
and
0.7.
0.45 plus.
0.7. Why it is? Because it said that takes at least one. What is the meaning of A union B? That means either A or B or both,
Or B.
correct? Exactly. So 70% takes the at least one. That means either A or B or both. That means either coffee or soda or both. So therefore, probability of A union B is given by 0.7. Okay. So now from this point of view, they have asked some questions. So just tell me one thing. Then first I read the problem. The question: what is the probability that a randomly selected adult regularly consumes both coffee and soda? So first question they have asked, what is the probability that the adult takes both coffee and soda? Can anyone tell me what
Intersection
is the
part.
situation? Just a second, exactly. So the adult takes both coffee and soda. That means, can I express the event in this fashion? Can I express the event in
Yes,
this
sir.
fashion? A
Yes, sir.
intersection B. So that probability I have to find, na, student? So that probability means what? Probability of A.
PA plus
Plus-
PB minus the union.
So can I calculate the number of this?
Yes,
Can I
sir.
calculate? Because I have the data na here. Just check. I have the value here actually. This value, this value, this value I have. By using it, I can easily calculate probability of A intersection B actually. I can easily calculate it. Which probability of A plus probability of B minus probability of A union B actually. Okay. So then that is the case actually. What is the probability that the randomly selected adult regularly consumes both coffee and soda? That line is extremely important. Both coffee and soda means both means intersection. Both means intersection. What is the probability that the randomly selected adult does not regularly consume at least one of these two products? Before that, first I'm asking one thing. Just tell me. Suppose in a bucket there is some apple and there is suppose some banana is there. So I am telling you to take at least one fruit. Suppose I am telling you to take at least one fruit. What is the meaning? Can anyone tell me? At least one fruit. What is the meaning? That means you can take.
A or
One also and both
B.
also.
That means you can take either apple or banana or apple and
Both.
banana both. Am I correct? Correct, no? So
Yes,
you
sir.
can take either apple or banana or apple and banana both. So right now, here the case, according to the question, that the adult does not consume at least once. The adult does not consume at least one. At least one. What is the meaning? What is the meaning? That means the person or the adult
Neither A,
is
neither
not
B.
taking, either the person is not taking coffee, correct? Or the person is not taking soda, correct? Or the person is not taking coffee plus soda. Am I correct? Please tell me.
Yes, sir.
Am I correct? The person does not consume at least one. That means the person is not taking either coffee, or the person is not taking soda, or the person is not taking coffee and soda, both actually. So now you tell me how to construct the events in this case whenever the person is taking coffee but not soda. Can anyone tell me how to construct the event when the person is taking coffee but not soda? From here, what is my event? First you see, what is my event? I have denoted A is the event, and the adult take
So
coffee.
PA minus the intersection.
What first I'm asking, the person takes coffee, but not soda. How to design the event? Anyone?
So PA minus the intersection.
PA union
P-
intersection.
PA minus
The PA and B intersection, sir.
no.
The PA intersection B minus PA.
See, I am writing by this fashion. Can I write in this way? The person takes coffee but not soda. Can I express the matter in this format? Please tell me, yes or no.
Yes,
Yes,
sir.
sir.
Yes, sir.
Can I express? Because A is the event that describes the person takes coffee, and B is the event that describes the person takes soda. But if I am giving B complement, that means that is the reverse case. That the other case that is not in B. So not in B means what? The person is not taking the soda. So if I am writing A intersection B, so that is the meaning of this. Now the person is taking coffee but not soda. Correct? Similarly, if I am writing B intersection A complement, what is the meaning? Tell
It
me.
consumes soda but not coffee.
Coffee, exactly. So now you tell me what is the meaning? The person is not taking. The person not taking both
So
soda and coffee.
A complement
Bolo.
intersection
complement
B
intersection B
complement.
complement.
Exactly. A complement intersection B complement, because the person is not taking soda, not taking coffee. So therefore, this event I want to express by A complement intersection B complement. Okay. So therefore, I have to basically calculate the probability of this. Am I correct? Please tell me yes or no.
Yes, sir.
This plus probability of A complement intersection B plus A complement intersection B complement. Basically, I have to find this probability. Am I correct?
Yes, sir.
Yes, sir.
So tell me, the person either can happen like this way, or the person can happen this event, or the person can happen this event. So can I say these events are pairwise disjoint event?
Yes, sir. Pairwise disjoint.
So what is my axiom number 3? What is my axiom number 3? Bolo? What is axiom 3? Bolo. What is axiom 3? If the events are pairwise disjoint, then
Union is equals to plus.
exactly, then union is equal to plus. So therefore, I can write this fashion. Please tell me yes or no. Am I correct? By the rule of axiom number 3. What is axiom 3? That is given by summation union of I is equal to 1 to infinity. That is given by summation of P of AI. Am I correct? Please tell me.
Yes, sir.
Yes, sir.
If A1, A2, A3 and dot, these are pairwise disjoint event. Just remember, these are pairwise disjoint event. And what is pairwise disjoint? Tell me, Bolo. That is AI intersection AJ is
I
equal
not
to
Equal to
5.
5.
I
Is
is
equal
not
to
equal
5.
to J.
AI intersection AJ is equal to 5 and
5.
I not is equal to
Not
J.
equal
Correct?
to J. Yes, sir.
Exactly. So on that basis, I can say these events are pairwise disjoint, and by using the axiom 3, I can say this is becomes probability of A intersection B complement plus probability of A complement intersection B and probability of A complement intersection B complement. Okay, that I can. Now I am telling you, can I calculate the value of probability of A intersection B complement? Bolo.
So we
Can
can
I
break it
calculate
down.
the value? Yes. Can I calculate probability
Yes,
of A
sir.
intersection B complement? What is the number? Anyone?
So probability of A minus probability of A intersection B.
That means I can think in this fashion, student. That is my A, that is my B, and that is my AB, correct? And A intersection B complement, that means I am talking about only this part. Am I correct?
Yes, sir.
Am I correct? This is my A intersection B complement. How can I write? That means I can write A is equal to A minus
B.
AB plus AB. But A minus AB what? That is basically AB complement, correct? This. But this is a pairwise, that is basically disjoint event. So I can write probability in terms of probability A is equal to probability of AB complement plus probability of AB. So from this line I can write probability of AB complement, that is probability of A minus probability of AB. Am I correct? Please tell me as well.
Yes, sir.
So can you
Exactly.
please repeat, sir, these lines, sir?
Okay.
It
So
got amount.
see, this is your total is A. Am I correct?
Yes, sir.
A. Achha. What about this part? Bolo, what about this
A
part?
intersection. A intersection B.
A intersection B. So what about this hazy part? Anyone? What about this hazy part? Bolo. That is A minus AB, correct?
Only A, sir.
Yes, sir.
Only A.
No, that is A minus AB. This part I
Yes,
am
sir. A
saying.
minus AB.
A minus AB, exactly. So this part is A minus AB. Okay. So can I write A is equal to A minus AB plus AB?
Yes, sir.
Correct. But what about A minus AB? That means A intersection B complement, correct? A intersection
A
B
minus
complement, you
AB.
just
Yes,
observe,
sir. Yes,
no?
sir.
Because
Yes, sir.
exactly A intersection B complement plus of AB. But can I say this event and this event are disjoint event? Can I say
AB.
only this part
Yes, sir.
and this part? Can I say therefore like this way is
Yes, sir.
coming now? This is one part and this is another part. Am I correct?
Yes, sir.
Exactly. So these are disjoint event. So
Yes,
I
sir.
can write probability of A is equal to probability of AB complement plus probability of AB. But probability of
Yes,
AB complement is what? Probability of A minus probability of AB. That I result I got. So now I am writing this actually become probability of A minus probability of AB. So now you tell me, can I get this number? Because I in my hand I have probability of A. I have probability of A intersection B. Can I find this number?
Yes, sir.
Tell me. Exactly. Similarly, can I find this number? A complement intersection B. Can I find this number like this way? That is probability of B minus probability of AB.
Probability of
Am I correct?
AB.
Yes, sir.
Correct. And what about this part? Probability of A complement intersection B complement. Tell me.
De Morgan's law.
Because that means probability of A union B
Whole complement.
complement. Correct. But that is what? 1 minus probability of
A intersection B.
A union B. Exactly. So from this, because this part already known to me, in the data it is given now, that is given by 70%. 70%
Yes,
of
sir.
the total population consumes both. At least one consumes. So that means this value is given by 0.7. So 1 minus 0.7, ultimately it comes 0.3.
0.3.
Exactly. So is it fine for everyone? Whatever I'm trying to say, please tell me that is the
Yes.
value. This value you have to calculate. Okay. So this number I can also write in this format, na student. A union B complement, correct? This
Yes,
last
sir.
line I can write na A union B complement. Now you see that value, whatever I have done. Dekho, is it fine for everyone? See this line. See this line. Dekho. Is it fine for everyone?
Yes, sir.
Everyone? Okay for everyone? A intersection B complement,
Yes, sir.
B intersection A complement, and A union B total
Yes,
complement.
sir.
Then they have calculated the total things and all the things they have done. Okay. So 0.77, 0.73 like this, they have done them. It's the final one. Okay. So Surjo, is it fine? Is it fine for Surjo? Saurabh, Rajashree,
Yes, sir.
okay. Ritu, is it fine?
Yes, sir.
Okay. और किसको पूछना है? Abhash 1872. Is it fine?
Yes, sir. Fine, sir.
Okay. So can I proceed?
Yes, sir.
Yes, sir.
Okay. So that problem again I have taken from the exercise. That is the electric dryer problem. You first check the exercise problem. Yes. 15. Consider type of closed dryer, gas or electric. That problem I have taken. Okay. That is the electric dryer problem. Very important problem. So that type of problem is extremely important. Okay. That's how I have taken from here. Okay, so right now I'm just going here. See, first we are reading the problem. Whatever the problem they have given, first we are reading one by one. Consider the type of clothes dryer. Consider the type of clothes dryer. Now, what type? Now, either gas or electric. So, therefore, the dryer for drying the clothes actually, either it is working by gas or it is working by electric. So, consider the type of clothes dryer purchased by each of 5 different customers. Purchased by each of 5 different customers at a certain store. Suppose there is a store and 5 different customers visited to purchase the dryer, clothes dryer, and suppose there are gas dryers are available, there are electric dryers also available. Suppose in the particular store. Now the 5 different customers have purchased 5 suppose clothes dryers, but you don't know which type of dryer they have purchased. That means it may be your gas dryer, it may be your electric dryer. Okay, anything can happen that you don't know in advance. Now, on that basis, they have asked some question. What type of question? Now, if the probability that at most one of these purchases an electric dryer is, that the probability that at most one of these purchases an electric dryer is 0.428, what is the probability that at least 2 purchase an electric dryer? Okay. Read the line again carefully. If the probability that at most one of these purchases an electric dryer, so you tell me, whenever I am telling that out of the 5 customers, at the most one customer buy gas dryer. What is the meaning? Can anyone tell me?
The maximum
At
one
the most-
customer can buy.
Therefore, I can say na, either 0 or 1, correct?
Yes, sir.
That means either 0 gas dryer purchased or 1 gas dryer purchased. Now, what is the electric dryer? So you by electric. Now, the case, what is the probability that at least 2 purchase an electric dryer? What is the case? What is the probability that at least 2 purchase electric dryer? So at least 2 electric dryer, at least 2 electric dryers, at least 2 electric dryers, DRYERS, at least 2 electric dryers purchased. What is the meaning? At least 2 means either
2 or more.
2,
2 or
3,
more.
4 or 5, correct?
Yes,
So if I denote is the event at the most one electric dryer purchased, and is the event that at the most one electric dryer purchased. At most one electric dryer purchased. Can anyone tell me what is E complement? Can anyone tell me what is E complement? First, you tell me what is E complement. The definition. Tell me. Those points that are not belongs to the set E. Am I correct?
Yes, sir.
Yes,
Those
sir.
points. So tell me, is the case at the most one electric dryer purchased? What is the complement?
So at
At
least
what
2.
is that?
At least 2.
At least 2. Very good. At least 2. So if I am interested to find the probability of E complement, what is the value?
So 1 minus E PE.
1 minus P of E, correct?
Sir.
1 minus P. But what about P? That means at the most one electric dryer purchased, that probability. Is it giving in your data? Is it giving in your data?
28.
Yes, sir.
At most one electric dryer is purchased, that is 0.428. So how to get the number?
So 1 minus 0.428.
428. So you are getting the value of probability E complement. What about E complement? At least 2 electric dryer is purchased. That probability. That is your question. First question. Check. What is the probability that at least 2 purchase an electric dryer? That is the main thing they have asked. So they have asked, what is the probability that at least 2 purchased an electric dryer, at least. So that's why I have written here probability of E complement. It is given by 1 minus 0.428 and you are getting the number. Now moving to the second part. What is second part? Second part, suppose they are telling, suppose P is a probability that all 5 purchase gas electric dryer, and another probability they have given all 5 purchase electric dryer. Okay, 0.116, 0.005. Okay, so they have given basically 2 things: the probability of all purchase gas dryer, that is 0.116, and probability of all purchase electric dryer. Okay. What is the question?
So 0.005.
0.005. Okay. 0.005. Now, what is the question? Question is, what is the probability that at least one of each type is purchased? Probability you have to calculate. Now, at least one of each type is purchased. Okay, at least one of each type is purchased. So now you tell me, is it possible? That means if I am buying 5 dryer, therefore there should be at least one either gas or electric dryer. Am I correct? If I am purchasing 5 dryer, okay, so that means there should be at least one either electric or gas dryer. Am I correct?
Yes, sir.
Yes, sir.
Exactly. So therefore, can I say that the case all purchase gas dryer and all purchase electric dryer, that complementary event basically at least one of each dryer is purchased? Can I say this?
Yes, sir. At least
All of you agree
one
with
is
me?
purchased.
Yes, sir.
All purchase gas dryer and all purchase electric dryer, the complement event is that at least one of each type is purchased. All of you agree with me or not? First you tell me.
Yes, sir.
Sulagna, Abbas, Saurabh, Ritubroto,
Yes, sir.
Yes, sir.
Priyangshu is there?
Yes, sir.
Yes, sir.
Okay.
Yes, yeah.
So everyone, so what I am left here. So at least one of each type is purchased. I can say that is a complement event of all purchased gas type and all purchased electric type. So that event, complementary event, is basically given by at least one of each type is purchased. So now you tell me, if I am denoting this is as my suppose A event, and suppose this is my B event, that means all purchased as gas dryer and all purchased electric dryer. So P of A is given by 0.116 and P of B is given by suppose 0.005. So can I write this is basically 1 minus probability of A minus probability of B? Can
Yes,
I write
sir.
this one? Please tell me. All of you agree with me or not? Tell me.
Yes, I agreed.
Exactly. Because that is, you think in this way. At least one of each type is purchased. The meaning is all purchased gas and all purchased electric dryer, that event, complementary event is, or at least one of each type is purchased. So therefore, you are writing 1 minus P, 1 minus P. So therefore, you are writing 1 minus 0.116 minus 0.00. So is it fine for everyone? Please tell me.
Yes, sir.
Okay.
Yes, sir.
So should I go to the next problem, or I should stop here? Tell me. Choice is yours. Otherwise, I will call the roll numbers.
We can go one more question.
I can go on more question. Okay. So, but the attendance I have to also take. Okay. So, let me try. Suppose, and how many students are there? First, I have to check 73. Just tell me who are absent. Just tell me. Then I will just absent those, and it will be okay. Okay. Just read the question. An individual is presented with 3 different glass of cola, okay, labeled C, D, and P. An individual is presented with 3 different, it is also exercise problem. An individual is presented with 3 different glass of cola, suppose label C, D, and P. That means what? Now, suppose there is a boy or girl, in front of him or her, there is 3 glass of cola. Okay, one label C, one is D, one is P. Now, he is asked to taste all 3 and then list them in order for preference. That means the person, I am telling the person, is provided 3 glass of drinks, but whenever the person is provided 3 glass of cola, so he will taste or she will taste. After tasting, he or she will give him or her preference. Preference means that is good, that is middle, that is means not good, like this. So on the so either some preference, that means the person want to taste first C, or first want to taste D, or first want to taste P, or first D, then P, then C, like this. Some label is there. On that basis, they have the person want to give some preference. Now, preference. Suppose the same cola has actually been put into the all glasses. Suppose Pepsi or Thumbs Up, whatever it may be. Suppose the thing is given here. It is basically same thing is provided. Okay, identical thing, same thing you have given, but the person want to give some preference, either CDP or DPC, like this. Then they have asked some questions. Now, what are the simple events in this ranking experiment, and what probability would you assign to each one? So, the person can taste this way, the person can taste DPC in this way, the person can taste DCP in this way. Am I correct? Please tell me yes or no.
Yes, sir.
Exactly. So in this way, it will proceed actually. So how many cases are there? You can observe there are 10 possible cases are there. Okay. So there are basically 6 sample points are there actually. 6 sample points are there. Here actually 6 sample points are there. Okay. That is one case. Now they are asking what is the probability or what is the chance. That means what is the probability that this will happen. That means the person first take D, then take P, then take C. What is the chance, or what is the case actually? What is the case? Since in each glass the same drinks or same sample or same soda is provided, that's why I can say each of these can happen equally. Am I correct?
Yes, sir.
Since same drink is provided to all the glass, so therefore I can say that each of these can happen equally. So therefore I can say chance of each means either this or this or that is what? That is my that is event point. Am I correct? That is
Yes,
my
sir.
event point. And the total is event space. And total is event space. Okay? Total is event space, and each of them is event point actually. So happening case or happening probability of each event point is given by number of point in each case divided by total number. So that is 1 by 6.
1 by
Is
6.
it fine for everyone? 1
Yes,
by
sir.
6. Now we'll see how they have given. The first case 1 by 6. Okay, because each case divided by 1 by 6. What is the second problem? Now, what is the probability that C is ranked first? What is the meaning C is ranked first? Anyone? That
So
means
C is ranked first, like it is taken
that means
first.
the person has taken the C level cola first time. Am I correct? Therefore, either this will happen or this will happen. Am I correct?
Yes, sir.
Yes, sir.
Therefore, what is the probability? Anyone?
2 by 6.
2 by 6.
1 by 3.
Therefore, 1 by 3. See. Am I correct?
Yes, sir.
2 by 3. Okay. And what about the last case? What is the probability that C is ranked first and D is ranked last? What is the case? Anyone?
So only
C
one.
is first, D is last. So what is the middle? Bolo?
So P.
P. So what is the case?
1
1
by
by
6.
6.
Am I correct?
Yes, sir.
So now I'm asking roll numbers. Just give the attendance. So is today's class fine?
Yes, sir.
Yes, sir.
Fine, sir.
So are you enjoying or not? I don't know. You are enjoying or not?
Sir, we are learning.
You are enjoying?
Yes, sir.
Okay.
Uh.
So give the attendance. Faculty self-service attendance. So just tell me who is absent. Mark attendance.